Continuity. We have already understood limit. Now we will understand continuity. See, continuity, wait a minute. Continuity, continuity implies limit exists. If function is continuous, that means limit is there. If limit is not, if I say no limit, or if I say no limit, implies no continuity. Continuity. In layman sense, in a very normal sense, for those who didn't have maths in class 11th and 12th, see, limit comes here, continuity comes here, differentiability comes here. See, if limit does not exist, then continuity cannot exist. And if continuity does not exist, then differentiability cannot exist. Like suppose this is your grandfather, this is your father, and this is you. Suppose your grandfather is not there, then there is you don't have your father and you don't have you. This way, that means if I say in a layman's, in a very normal terms, if limit does not exist, then continuity will not be there, differentiability will not be there. See, grandfather is there, it's not necessary father and you would be there. But if grandfather is not there, then none of them will be here. That's the idea basically. That means this is the direction. That means if you are there, that means all of them are there. If differentiability is there, then continuity and limit is always there. Got the point or not? That's the idea basically behind continuity. Let us understand in more simple manner, another diagrammatical manner. समझने की कोशिश करो. अगर लिमिट है, अगर डिफरेंशिएबिलिटी है, तो कंटिन्यूटी भी होगा, लिमिट भी होगा. जैसे मैंने अभी बताया कि this is your grandfather, this is your father, and this is you. If you are there, of course your father is also there and your grandfather is also there. Without them you wouldn't have been here. But if the grandfather is not there, then none of them would have taken place. Suppose grandfather is there, but then continuity may or may not exist. That's why I'm writing differentiability in one line. Differentiability. Just wait a minute. Differentiability implies continuity in one way. Wait a minute. Continuity in one line. Continuity implies limit. This way it is easier to remember. So this happens, then this is also there, then this is also there. Limit is there, so other way around. No limit implies not continuous, not continuous, not differentiable, not differentiable, differentiable, not differentiable. This is the other way around. This is the way you have to remember. This way, actually, this is the way. No limit implies not continuous, not differentiable. So, suppose limit exists and it is not continuous. So, this is not continuous implies not differentiable. But this is the way you have to remember. See, a function can have continuity, can have limit but no continuity. That could be possible. A function may have limit and continuity but no differentiability. I'll give you examples of this. I hope you have understood this point here. This is the thing which you need to keep in mind. This is the thing you need to keep in mind. This diagram. Differentiability implies continuity, implies limit. If it is differentiable, then it has continuity, it has limit. No limit means not continuous, not differentiable. That's the point. So let's now let us start with a small little more explanation on this. Suppose this is your river going. This is your left side. This is your right side, and here it is called, the point is somewhere here. This is point A. This is the A plus, that is the right hand limit. That is the right hand limit. This is the A on the minus, that is the left hand limit. Both are at the same level, means both limit exist. But suppose the bridge is somewhere here, then it is not continuous. The bridge is at a different level, then it is not continuous. The bridge, That means there should be a bridge here to make this two connections on this river like this. Now the bridge should be of the same level. That means the value of the function, see the limit of the function here is say L. The limit of the function is here also L. The value of the function at this point, value of the function at A should also be L. If it is different than then it is not continuous. This is a very easier way to understand this diagram I made. Now let's come to it problems. Let us understand what exactly is content. This all was the introduction. Now the classical definition of continuity, the formal definition, formal definition, definition, formal definition is limit, well, not this one, wait, this is this one. Earlier you wrote fx minus L, now you write fx minus f of A mod is less than epsilon whenever, whenever x minus A is less than delta. This is the formal definition. The other definition is limit x tending to A, f of x is equal to f of A. That is the point. Earlier you used to write this L. Now the value of the function at the point should be same as that of the limit. जो वैल्यू फंक्शन का होगा वही लिमिट की वैल्यू के बराबर होना चाहिए. अच्छा अब देखो, now this point on this, now I'll do some problems on this. I'll do some problems now. Let's come down. Let's start doing problems on this. The problems would be very simple. Now before that, let's talk about uh, discontinuity. What do you mean by discontinuity? Suppose, what are the chances of discontinuity? Number one chance, limit, limit exists, limit extending to A, fx. Let's write down this way, wait a minute. Limit, limit extending to A, fx exists. Fine, but limit extending to A, fx is not equal to f of A, not equal to, then this is called removable discontinuity. Removable discontinuity. Because I can define the value of fa equal to fx somewhere, limit at x equal to a fx, and then I can make it continuous. It's called removable discontinuity. Removable discontinuity. Discontinuity. I'll give you an example with this. See an example. Let us see an example. We have done this type of problem earlier. Let us see this problem. Let me do this here. I had showed you fx equal to, I had taken this type of function sin x by x and not at x not equal to 0, and I had suppose I write 1 here at x equal to 0. Now we already found out the limit in my previous video, limit RHL x tending to 0 plus sine x by x, floor function, we did this, we got 0. Limit at x tending to 0 minus sine x by x on the floor function was again 0. This was also there. Now both the limit exist. Both the limit are same. So the limit exists. See here. Let me take it here a little bit. Yes. See, both the limit exist. Limit x tending to 0 plus fx is equal to limit x tending to 0 minus fx. And so limit x tending to 0, this sine x, fx means this, I'm talking about this fx, this one. Sine x upon x is 0. But this is not equal to 1, because 1 at 0, this is not equal to, I mean to say, is not equal to 1. And what is this equal to? 1 is what is f at 0. देखो ये लिमिट एग्जिस्ट कर रहा है, राइट भी लिमिट कर रहा है, लेफ्ट हैंड भी लिमिट एग्जिस्ट कर रहा है, दोनों लिमिट बराबर है, दोनों लिमिट बराबर, लिमिट एग्जिस्ट कर रहा है, उसकी वैल्यू क्या है 0. मतलब उस जो फंक्शन की वैल्यू है एट 0 पे वो क्या दे रखा है 1. डोंट थिंक दिस इज दैट पॉइंट. पॉइंट इज 0. दिस इज ऑन द राइट साइड ऑफ 0, दिस इज ऑन द लेफ्ट साइड ऑफ 0. दोनों लिमिट बराबर है. द राइट साइड ऑफ 0 एंड द लेफ्ट साइड ऑफ 0, द लिमिट इज सेम. द लिमिट इज सेम हियर. So the limit undoubtedly exists. but the value of the function at 0 is 1. So the function is not continuous. In order to make this function continuous, I'll redefine this function like this. Now you see. I'll now redefine the function like this. See, I will now redefine the function. I'll redefine the function fx equal to, I'll write like this. For function sin x upon x, for x not equal to 0. Earlier 1 लिखा हुआ था, now earlier it was written 1, now I'll write 0 at x equal to 0. Now you will see limit. Already we have seen this. The limit at x tending to 0 fx, where fx is this quantity for 0 plus and 0 minus, is now equal to f of 0. Now the function has become continuous. When I have redefined the function here, it was earlier 1, now I made it 0. The function has now become continuous. This is called removable discontinuity. This is called removable discontinuity. And let me tell you one more thing. Now the next type of discontinuity is, this was the removable. The next is discontinuity of the first kind. That is, let us take this example. Let us take this example. Let us take second case. Let us take an example. See, if that is, if uh, limit does not exist, if limit x f x does not exist, that means does not exist means limit x tending to the right hand limit fx is not equal to the limit x tending to a minus fx. So both the limit exist, both right hand and left hand exist. Let me write, both right hand limit and left hand limit exist, but are not equal, then it is called discontinuity of the first kind. Then it is called, this is called discontinuity of the first kind. Discontinuity of first kind, of first kind. Now take an example. We'll take an example right now. See this. We will now take an example. Wait a minute. We'll take an example. See, just a minute, let me check here. Yes. Now you take fx is equal to mod x upon x for x not equal to 0, and say 1 for x equal to 0. At the point 0, the function is having value 1. That means f of 0, it is giving 1 actually. That actually means this. Now see this. Now if I take RHD, sorry, right RHL, limit, right hand limit x tending to 0 plus mod x upon x gives me limit x tending to 0 x upon x, and this gives me 1. The limit is existing. Now you see here, limit x tending to 0 minus mod x upon x. This gives me limit x tending to 0 minus, this is plus, sorry. This is minus x upon x. I did it earlier. It was coming minus 1. This is also existing. Both of them are existing. Both of them need to exist. दोनों होना चाहिए. दोनों exist होना चाहिए. और दोनों बराबर नहीं होना चाहिए. Both should exist and they should not be equal. Then it is called discontinuity of the first kind. Then it is called, this is the example of discontinuity of the first kind. Limit x tending to 0 plus mod x upon x is not equal to limit x tending to 0 minus mod x upon x, but they are both existing. Therefore, this is called discontinuity of the first kind. Now, let us see a discontinuity of the second kind. What does it mean? What does this mean? Discontinuity of the second kind. Let us understand this. If either the right hand limit or left hand limit, or both don't exist, do not exist, do not, oh, wait a minute, do not exist, then it is, take C, then it is called, it is called discontinuity, discontinuity, discontinuity of the second kind. This, wait a minute, I think I made a mistake here. Wait a minute. Discontinuity, continuity of second kind. See an example. I did this type example with you earlier. मैंने पहले किया ये सारा example. Limit पढ़ाते वक्त. ये देखो. See this. Let me define fx equal to sine greatest integer function x and upon greatest integer function x for x not equal to 0 and let's say 1 at x equal to 0. Let's say. Now in that case, we have already then LHD, LHD, LHL came out to be limit x tending to 0 plus 0 minus f of x. F of x means this quantity. Limit x tending to 0 minus, sorry, wait a minute. Sine x, sine x, floor function gave us sine 1. I hope you remember. I did it. And in case of the RHL, I'm talking about the RHL. In case of RHL, limit x tending to 0 plus fx gave me limit x tending to 0 plus, I got sine 0 upon 0, which is absurd, does not exist, does not exist. So one of the limit is not existing. So this is called discontinuity of the second kind. This is called discontinuity of the second kind.